Hello and welcome to today's webinar. On behalf of Intelligent Transport and Brugg eConnect, I would like to thank you all for attending. My name is Leah Hockley. I'm the editor of Intelligent Transport and I will be moderating the audience Q&A at the end of this webinar. Joining us today is Patrick Kern, CEO at Brugg eConnect, Stuart Portvic, Manager of Electromobility at the Agency for Urban Environment at the City of Oslo, Sarah Kalsas, Mobility Advisor at the Agency for Urban Environment at the City of Oslo, and Tommy Ristamaki, Chief Executive Officer at Kempower. Today, each of these speakers will all be discussing the future of zero-emission transportation, with a particular focus on the Norwegian City of Oslo's work in this space, as well as what is needed in order to ensure a successful transition to e-mobility. Following today's presentations and discussion, we will move on to a live Q&A session where you can pose your questions to the speakers. Please remember that you can submit your questions at any point during the webinar using the questions panel situated in the menu on the right. So without further ado, I would now like to hand over to Patrick for our first presentation today.
Thank you, Chloe. My name is Patrick Kern, CEO of Brugg eConnect, and proud to present the activities for the electric cars. Brugg eConnect is divided in three market segments: on industry on the right side, in wind in the middle, and the DC fast charging e-mobility activity. The market for electrically powered vehicle is growing rapidly in Europe. In Germany, for example, around 2% of all passengers' cars are now electric, which corresponds to almost 1 million electric cars out of 50 million registered passengers' cars in Germany. Nevertheless, we are still a long way from zero emission to transport today. In this, you see the new technologies always takes time to catch on. Fortunately, Europe is now slowly reaching the early majority, which means that the technology is now catching on with the general population. This you see on the both curves. Nevertheless, many people are still hesitant about buying a BEV. We see possibility causes in the following points. Charging possibilities at home. The investment cost for an AC charging station at home are also very different and should not be underestimated. It is not possible for everyone to have their own charging station at home or at work. Different challenges for home owners, apartments, owners and tenants. On the road, the middle one. The ranges today are half those offered by conventional vehicles. Charging still takes about 1 hour on average. The best charging station takes probably around 15 minutes for 80% of the loading activities. For that, we need the infrastructure. More and more for electric vehicles, but not enough charging possibility, actually. Large country-specific difference in land infrastructure, for example, in Poland, also make traveling more difficult, which certainly still prevents many users from making the switch. With our innovative solutions, we want to help remove these obstacles and thereby accelerate the switches for private individuals to electrically powered vehicles. For that, we have our user benefits. We have the best performing cable without cooling. With our PureWheel Connect 500 DC fast charging system, users can already reach 80% charging capacity in just 15 minutes. At the moment, we are the only supplier that can deliver constant charging currents up to 300 amps in uncooled form on the market. We have another opportunity. This is the battery charging in less than 10 minutes with the PureWheel Connect Cooled 850 Plus. We have this DC charging system in the pipeline that reduces the charging of an electrically powered vehicle to less than 10 minutes. thereby elimination the additional time requirement for end users. And this is the most important thing. For this, we want to be a technology leader. This we are dividing in several positions. One of this, we want to be a pioneer. As one of the first companies to launch DC charging cables in Europe, we have already built a broad know-how and brand. The second step is the quality. The quality, proven quality and long service life of our DC charging cables installed in Europe. The system provider is also, we are one of the only manufacturer of cables and connectors in the market. The next step is the non-cooler charging cable and contacts that can reach 500 amps peak power with a light weight and high flexibility. And the last step is the cooler cable with power contacts that can withstand continuous currents up to 850 amps and at an ambient temperature up to 50 degrees. For that, we have plug properties. And these plug properties we have in a classic line, in a compact line, and the last step is the easy to maintain. These both plugs are available as a system solution in the Purwheel Connect or Purwheel Connect cooled version. This is easy to maintain. The connector face frame and the AC contacts are easily and safely replaceable within minutes. With our compact plug, we got one step further in terms of robustness and safety. Due of their weight, the plugs fail off quickly as a result, but also due to vandalism, damaged plugs are encountered time and again. For this reason, we have created a connector with our compact connector that offers maximum safety under very heavy strain. This is that in the middle as the safest plug worldwide. What are the user benefits of them? This means that our world normally meets the highest technical feasible possible standards and is resistant to hydrolysis, UV, ozone, and oxygen. The connector owes especially robustness and to its housing, which has been injected with thermoplastic polyurethane. This means that the housing can even be rolled over by a truck without being damaged. The number 6 means dust-proof, and the number 9 at the end is the protection against water during high-pressure stream jet cleaning. We have the world first IP69 certificated charging plug in the world. What is also important for the users? The guarantee loyalty. That means we are more sensitive. Key elements of this charging system are replaceable, ensuring a much longer life for the charging station. The maintenance, which also is really important in this case, is downtime can be minimized by a quick replacement. Also, this substantially that we can put the front face can be replaced within minutes if it's damaged. What can be the next step in these cases? The next step, we are calling them megawatt charging system. In order to be able to guarantee emission-free transport in the future, all commercial vehicles must also become electrically. Commercial vehicles, such as trucks, agriculture vehicles, both, and aircraft play an important role there. In order to these vehicles to keep up in everyday business, much higher charging currents must be able to be transmitted much faster. We are currently developing a megawatt charger for this purpose. Translate to achieve current of more than 1000 amps. A new interface is required as a first step shown. That with a cable of 40 millimeters diameter and a weight of 3 kilograms per meter, power can be up to 300 amps, which can be achieved. To achieve current more than 1000 amps, a new interface is required. That will be this 40 millimeters diameters. and it will be a voltage up to 1500 amps volts, and it is a cooled cable. Right now I would go over to Sture and to Sarah. Thanks a lot.
Thank you so much. We will be talking about the electrification of transport in Oslo. What we see is the key to the zero-emission city. Oslo started with electrifying transport really early, back in 2008, with a 10-point plan to reduce carbon emissions. Because we saw that with over 60% of the emissions in Oslo coming from transport, the way to reduce emissions was to do something about transport. So we started putting up chargers in 2008, and our vision was kind of seeing is believing, that when you see chargers, you see you have a possibility to buy an EV and charge it, more people will do so. And the pictures down to the left is from an EV parade quite a few years ago. And to the right, you can see politicians opening a fast charging station. Today, we focus more on electrifying all types of transport. We started with the private cars, but are moving more towards commercial vans, heavy trucks, shared vehicles, taxis, and of course, all private cars. In addition to that, all public transportation must also be electric. So that's quite a challenge. The EV sales in Oslo are boosting. Over 90% of new bought cars are electric, which is really good. We can see them everywhere in Oslo. And the share of EVs and plug-in hybrid sales has reached 92% in 2022 so far. So with 9 out of 10 vehicles sold are electric, Oslo has become the first mass market for EVs, which is really great. In the graph down in the bottom half of the slide, you can see the development of how the EV share has increased in Norway from 2010 to 2020. So that's quite a dramatic boost in just 10 years. So we see this is not rocket science. Green taxes are working, and our goal is to make it affordable for people to take green choices. And here we can see that the top 10 selling car models in Oslo last year was 9 of them were battery electric cars, and 1 was a plug-in hybrid. So that's also quite impressive, and it's quite a good variety of the models as well. And in 2022, we have almost only battery electric cars in the top 10 selling list. And a fun fact was that it's actually now sold more electric Porsche Taycans in Norway than the diesel model. Sture, over to you.
Yeah, thank you, Sarah. Yeah, Sarah mentioned it. It's not rocket science, but you need a stable and steady policy, and it's 3 important measures. You have to make an EV cheap to buy, but also cheap to use, meaning free parking, free electricity, and also free passing in the toll roads in and out of the city. So cheap to buy, cheap to use, but also practical and convenient. And the last point is where me and Sarah comes in. We have to make sure that everybody can charge, not only the private cars, but also the taxis, the shared vehicles, and of course the trucks. So, but I have to be honest, you also need the right product. So we had a stable policy since mid-90s, but nothing did really happen before 2011. And what happened in 2011? Well, you got Tesla, no, you got Nissan Leaf. That was for the first time an EV looked like a proper car. And the same happened in 2012 with the Tesla S model and later with the e-Golf. So if you compare, if you look at the slide down to the left, you can see a comparison of the prices for a car. If you look in the middle, you can see Tesla 3, Europe's most sold model, regardless of driveline. And of course, it's far cheaper in Norway than in Sweden. It's not rocket science, it's a matter of policy. Next slide, please. Also we had some local champions and pioneers like the pop band. You need a band to succeed. We had AHA, you all heard Take On Me, the 80s favorite, but also we had the Crown Prince. His Majesty was actually driving a small electric car, I think, for many years. And of course that helps awareness. So I think you need a pop band and you need politicians and also royalties to spice it up. Next slide, please. At the slide you can see to the right is a picture of a donkey. You need both the carrot and the stick. You need enough power and incentive to break through the wall. You need a big frontal sweep, so you need to make an EV cheap to buy, cheap to use, and also practical. So it's a lot of different incentives. And I think it was a win-win situation in Norway because the national and local government with the city, as we represent, were pulling in the same direction. The national state made and the treasury made an EV cheap to buy. We made it extremely cheap to use. So together, that was the way to do it. To the right in the middle, you can see the king. It was in 73, the oil crisis. He was taking the metro, so representing the national government in a way. And his son were driving and I think a Norwegian EV for many, many years. Next slide, please. Next, Sarah. Okay. Yeah. Catchword, big frontal sweep, public tenders, zero-emission zone, car-free city centers, and of course, walking like you're talking. The city's own fleet must be 100% clean. The public transportation is king, but it has to be clean and zero-emission. Also, you have diesel ban. All the taxis to get a license in November 24, they have to drive zero-emission. You can see the pictures there. Up to the right, you can see if you had an EV, you could use the bus lane. And I can assure you, it's a fantastic feeling driving into work in the morning and just passing the queue. You should test it. It's recommendable. In the middle, you need innovation to make things more cost efficient, but also space efficient. So we are testing out for the first time taxi ranks with fast wireless charging, first in the world. Down to the right, even the ferries are going to be electrified. So yeah, that's just an example. Next slide, and then you can take it over, Sarah.
So as I said, we see electrification of transport as the key to the zero emission. Oslo has very ambitious goals. By 2030, we will cut 95% of the CO2 emissions. And that's not an easy job, but by electrifying transport, we can get really far ahead to going there. And here you can see some of Oslo's goals. So, for example, 100% of new passenger cars sold will be electric within 2025. And also 100% of new vans, and 2025 is just 3 years until, so that will be exciting. We are in a hurry to reach our goals. And also 100% of heavy vans and trucks will be electric by 2030. And as Stu mentioned, all taxis in the city has to be electric from November 2024. In addition, we're working on the city buses, getting all of them electric. We have quite a lot of electric buses now, but are still a way to go there. Zero-emission deliveries will also be really important, as we see that there's a lot of freight vehicles in the city. And also the entire public transportation it should be electric from 2028, and this includes all buses and ferries, etc. And so in Oslo we have about 2,200 public charging points, and that's the picture you see to the left. And we have around 350 quick chargers. Now that's to the right, an example of that. And so in terms of quick chargers, we have different brands and different companies we are collaborating with. Our model is a joint venture between us, the city, and the private charging companies through public tenders. And what we do is that we split the investment costs, and the site and the infrastructure underground is owned by us, the city, and the chargers is owned by the private charging companies. We also then split the profits. And this, we're quite happy with this model. It seems to work really well. And we get to collaborate with a lot of different charging operators. Yes, so in this model, the return of investment is about 2 to 4 years. Sture, you want to take this?
Okay, yeah. Sarah mentioned fast chargers, DC, and also the curbside AC chargers, very important network. But even more important is actually to make sure that people can charge at home. So we have a subsidy scheme for housing cooperatives and associations, so they can actually get a subsidy from the city. And the last 3 years, we have subsidized like 60,000 chargers on private ground. And that saves a lot of space in the city, and it also more convenient for the user, and in addition is much cheaper for the city. Down to the right you can see a typical housing association. Many of them are not so into EVs charging and stuff like that, so that could probably be the first time they see a charger. Also, we have been involved in various EU programs together with nice partners from the Netherlands, Belgium, UK, Germany, and so on, for smart charging. One of them was called green charging, where the scope was actually to electrify a whole housing association with 250 chargers connected to renewables, solar panel on the roof, battery storage, and feeding also the grid back in a bidirectional manner. So a fantastic system, but yeah, just an example. But 60,000 chargers we have supported on private ground. Next slide, please. And the result, well, 30% of all cars today is actually electric in Oslo, and the sales figure, like Sarah showed you, 92%. So things are moving extremely fast, much faster than even the more optimistic among us had anticipated. So that's fantastic. It's good, but we're not yet there. I just have to stress that. Also, it has become a little bit crowded in the bus lane, coming back to that. And to the right, you can see a huge batch of Xpeng cars from China, and it's a good, have a nice trip to Norway, something like that. That's a nice gesture. In the middle, you can see a lot of Teslas. Down to the right, you can see the Volkswagen importer picking up the new ID3. Proud guy. Okay, what has this resulted in? according to DNV, we have 250,000 more battery electric cars than if this policy wasn't in place. We have saved like 60,000 million tons of CO2 in the period just in Norway. But it's also a huge indirect effect, which is important because it helps boosting the market. Keeping in mind that 40% of all Tesla sold in Europe in 2015 were actually sold to Norway, a small country. It's ridiculous, but it helped to boost the industry. Next slide, and then you can take over, Sarah.
Yeah, like I said, we have a lot of public-private partnerships, and we see this as really important and as a key for success. Like I mentioned, we are cooperating in the fast charging. We also have created charging hubs for freight electric vehicles, for example, Oslo City Hub, which is sort of a consolidation center where large trucks come in with goods and then they get moved onto smaller trucks or vans that drive electric around the city, so that all the freight can be electric inside the city. We have also, like Studio mentioned, have the wireless fast charging for electric taxis, which is a very cool, innovative project. We have done a lot of EU projects, and we continue to do that as well now. We're working on shared mobility, which we see will likely become really important in the future. And we're always looking for more innovative projects and pre-commercial projects to help continue boosting this shift. So, Sture, sky's the limit in paradise.
Okay, Sarah. Well, then the question is, you've seen that it's really taken off the sales of EV, but then you get the question, sky is the limit or trouble in paradise? Obviously, there are some challenges. You can see the image up to the left. That was the bus lane, but where is the bus? Well, I can see one bus and a couple of taxis if I look very carefully, but the other are private cars. So we had to adjust the policy a little bit, just work it a little bit. So now you have to be at least 2 persons in an EV to drive the bus lane in the rush hour. And then you get, as a bonus, a kind of car sharing, and that's good. More and more people are doing that, and now it's not that crowded. But of course, new regulations always makes people very creative. So down to the left, it was the first day. One guy was stopped using the bus lane. He was driving alone, but he had his inflatable doll. But he was stopped, and of course, then the police stopped him together with Norway's biggest newspaper. So he really made the headline. I guess the fine is pretty high, so I don't think he will do that anymore. But yeah, that's how it works. Next slide, please. Okay, yeah, there are challenges. Limited space or land is indeed a challenge. You have local grid capacity. Even if the national grid, the regional grid is sufficient, well, locally it can be a challenge. And that is a bit costly and takes a little bit more time than we really like. But anyway, that's life. And also, of course, the fact that the market is moving so fast, it's hard to deploy chargers fast enough. And sometimes I feel a little bit like the lady down to the right, running after the train in the morning, but the train is moving faster and faster every day. So it's hard to catch up with enough deployment of chargers. Yeah, a little bit crowded in the bus lane. Yes, there are some red tape. Long case processing time, we have to look up on that. And of course, 61% of the people in the city are not living in detached villas. Some are they are living in flats, and not all of them, 30%, does not have their own private parking. So we have to help them with both parking, but also charging. And of course, like Sarah mentioned, we have more and more focus on professional users of EV, like freight vans, taxis, etc. Next slide, please. Yeah, tailor-made hubs for freight electric vehicles. Sarah mentioned Oslo City Hub. We are working on a couple others, so that's important. Make sure that we have consolidation, all city logistics, zero emission. And yeah, we are really working on that and some very nice models. Next slide, please. 35% of all the vans at the moment are actually electric. So that's sold. So that's fantastic. It was 20% last year, so things are moving very fast. When it comes to the heavier truck, it's a little bit more challenging, but at the moment, 10 to 12%. So not bad at all. The carriers expect to have much more. And the reason up to the left, here you can see them at the traditional quick charging station, and of course they are not built for it. It's electric dump trucks, 16 tons, and the small BMW i3 are squeezed in the middle, so it's not perfect. We need tailor-made solution. Next slide, please. Electric taxis, yes. In 3 years, all taxis have to be zero emission, or otherwise they don't get a license. Next slide. Yeah, you can take that one, Sarah.
Yes, so we're also trying to create zero-emission building sites. And when we made the wireless charging station, we saw the opportunity to also get enough electricity to have a zero-emission building site, which we managed to do, and all the diggers and trucks and everything was electric. So that was really a cool project. And as I mentioned, we're also electrifying the public transport system. And on the picture down to the right, you can see an example of a bus charging. And we also have green mobility houses. These, the pictures on the right is where we converted an old bomb shelter to a parking garage, which is only reserved for EVs. So they drive down to the bomb shelter, and then there's 85 chargers down there. But like I say, we're always looking for innovative solutions to both reduce cost, save space, and increase the user friendliness. The picture on the bottom right is an example of a charging container, and that's something that we're looking into as an interesting way to have temporary charging. But we're always looking for new ways to do this in an even smarter and better way. And here's just some other examples of new methods and ways to do things. And as we mentioned, a green shift in transport is needed in total, and it's really important to have a holistic approach. So EV is just a part of the puzzle, and it's an important part, but the whole everything is connected to everything, and we need to have both more public transportation, which is the absolutely most important part, and the public transportation needs to be zero emission. And we're also increasing our focus on pedestrian and cyclists, and on car sharing or mobility as a service. Yes, we're also doing zero emission zones, trying to work out how we can establish that in Oslo. And in addition to that, we have a lot of other tools in our toolbox to try and make transport more green. Yes, is that the last slide? Probably.
Yeah, that's the last one, Sarah. Yeah. Anyway, yeah.
There we go.
Okay, thank you, Sarah. Holistic view, and in the future, everything is going to be electrified. Even the big container ships down to the left, autonomous. You don't need a captain in the future. Legally, you need it in a couple of more years. Up to the left is even domestic aviation is supposed to be fully electric within 2036, and that's really taking range anxiety up to new heights, literally speaking. So that's fun. And also, of course, wireless charging, also not only of taxis, but also of trucks and buses. In the middle there, Sarah, I can see you driving an electric high-speed ferry, and that's fun. In ferries, the maritime sector. And down to the right, it's an autonomous electric minibus at Svalbard, and it's nice to see an encounter with that autonomous vehicle and a polar bear, maybe in the future. But that's it for us, Sarah. So yeah, thank you.
Thank you very much.
Then going to the next subject, and so hello from my side from Kempower, and I'm going to have a, let's say, a different example from the charging world, and talking about intelligent charging solutions for public transportation, but touching also the other parts of the charging industry in the same way, or in the same presentation. First, couple of words myself. So I'm the CEO of Kempower, and from the background is electrical engineer. And really an EV enthusiast today. And this is actually describing the people at Kempower very well. I think we have compared to Finland, we have a higher number of EV drivers within the company. I think we calculate something like 35% of the employees is driving an EV. And have been in 20 years in the electrification and the last 10 years pushing the e-mobility through. First from the vehicle tech side, and was interesting to see the construction vehicles moving to electric, because most of those in Oslo were my old projects as well. But then looking at Kempower as a company, so we are Finnish electric vehicle fast charging equipment manufacturer, working from powers from 40 kilowatt and up. There is no absolute limit actually there, and we are working with all kinds of electric vehicles today. And with vehicles, I'm meaning also the ones that move on water, and maybe through the air as well, if that standardizes to as a normal in the future. Kempower as a company is a new company, but the strong history in the background. So we have been, charging business has been as an own company within the company group since 2017. But that includes that our company group where Kempower was born is more than 70 years of experience in DC power supplies, and actually in demanding conditions, so coming from welding industry and heavy applications, which fits very well as a good background of making reliable charging equipment. And it also describes the market, the growth is 760% growth with a 27.4 million euros last year, and today working from 2 factories here in Lahti, Finland, and actually expanding into Europe very fast as we see the market growing in there. Seems that it's jumping back and forth. But let's get into the subject and talking about intelligent charging systems and what kind of things are possible in the world. So in a nutshell, we have taken a little bit different kind of approach into the charging infrastructure building. So we are not building what you call standalone chargers that you occupy the parking places, the bus sites, as a complete units and are working as a separate entities. So we are splitting the system into having the actual charging electronics in centralized location. far away, it could be even 50 meters away from the site, and then intelligently dividing the power to the vehicles based on the needs from the vehicles and based on the needs on the charging curve in different sites. And I took the picture here to example that also if we have a high power bus charging, for example, through the roof, that investment could be also used in a dynamic system also to power up the electric cars. So that the investment and also the limited grid connections on the sites could be utilized to the best possible way, and actually making a system that makes sense in all aspects, and the usability of the equipment is as high as possible. And then looking at charging, and it's very much like you look at Kempower as a hardware manufacturer, but today this is a lot more, because when you're looking at total cost of ownership, for example, like I took the example from the public transport today, what we are doing behind the scenes is also that you are controlling the whole site in a way to make it intelligent, in a way that you save the cost and save the energy, and not only looking at it from the needs of the one vehicle. And for us, this means the ChargeEye cloud solutions as a software as a service, thinking from the basic to master level. But what you can actually achieve here, first of all, when you're looking at the hardware, it's interesting to see that when you intelligently control the power capacity throughout the charging cycles, which also one reason I took the buses as an example, because they have normally a longer period that they are charging. You can actually limit the amount of needed capital expenditure. So actually using the equipment to basically limit the powers that the site needs. Because when you would do this as a separate chargers, your grid connection and the energy usage is more or less a standalone thinking, and when you're looking at it from the system aspect, you can actually limit the peaks to whatever levels you want to, and the system itself is then dividing the power throughout the usable time. This would apply in the same way for logistic vehicles or looking at taxi fleets as a control point, because this can also give benefits in many ways. And then looking at actually when you're looking at capital spend, or let's say capacity of charging equipment, in many bus sites, basically this leads to less power installed, which can achieve the same thing. This would actually mean for personal cars in the same way that with the lower power, you can actually have a higher input because you split the power more evenly to the vehicles on exact needs. And as the vehicle batteries are getting ready, you free the power to the next one, and you immediately transfer it to the vehicle that needs it. But also when you're minimizing the grid connection tariffs and reducing the total energy consumption, that leads to even higher savings in the operating expenses, meaning the price of electricity. And this is also key when we are talking about really sustainable solutions. How to divide the power in cities and how to provide the power in the grids is in the key position on making clever installations in there. This kind of a solution thinking on charging sites is very important, because even we are building today quite big personal vehicle sites. For example, in Norway, typical site would be 16 high power chargers in a single site, or 32 high power chargers in a single site with Kempower solution. In bus charging, the DC charging or fast charging sites could be more than 100 vehicles charged at the same time in the same site. So this is something that the powers are getting a lot higher. And also as an example from Oslo, there is several big ferries and we have other high power vehicles like trucks moving into electricity, and then basically there is still limits in the grids. There's limits in there in the let's say the whole infrastructure. Then the clever solution helps making a good system. Then looking at also with these needs from a total system perspective means a total integration and intelligent transfer of knowledge. And today's charging equipment, of course, are connected online all the time. But normally this is used basically to look at the availability or looking at the pricing management. But in a larger charging sites, the integration of the charging system is needed to actually make everything smooth and seamless, and provide really the real-time, let's say, information that you can actually control. And this gives possibilities actually to affect also the power consumption, and also sell the services to the grid companies. And looking at it from the bus operator's perspective in this example is something that even looking at our solutions, normally people are looking just to hardware, but looking at the usability aspect for bus charging, the key is to get the vehicles moving exactly at the needed times. And to save more energy when you know the basically the leaving times, you're also making sure that the battery is actually full and warm when the vehicles leave for their use. And basically the cabin also in the public transportation is warm enough for the driver to come in and start taking passengers. So basically this is giving a lot of benefits in that aspect, and giving a really good example what the system thinking in charging business could look like for other industries as well. And a couple of examples from actual sites delivered last year. So the first one is from Sweden, where we are charging 51 electric buses in a single site. And there was also the requirement that the bus operator needs the units to be transferred to another site within a certain time. So it was delivered as a, let's say, ground, on top of the ground mounting, and actually it was ready, installed by our partner Ladalliansen in Sweden, in a way that the final installation was 1.5 days to have a 51 fast chargers in a single site, and it could be removed also with the same time. And in here the key is basically that you also dynamically share the power between the sites and different cycles, and you are making sure with an intelligent systems that the vehicles are warm and the batteries are warm, because this is also one key in the thinking when you understand electric vehicles, that if the battery is not warm and it's not charged at the last minute, let's say when the bus leaves, then you're using extra energy to warm up the battery during the run. And this could be expanded also in different kind of thinking. So typically as a Kempower, people see the satellites used to charge the personal cars, but we are seeing actually the pantograph charging through the roof as just a single input to charge a vehicle. And you could use the same similar kind wireless charging as a so-called satellite charging. You could dynamically share the power. So this is a picture of an indoor charging facility here in our hometown, where they have 20 electric buses in a city transportation, handled because of the space requirement. The roof charging made sense to there, but we are actually sharing powers from 120 kilowatt to 20 kilowatt during the charging cycle of the buses to make it clever and actually limit the grid connection and limit the energy use in the site. But you could also use it in the same way in a high power charging. This is a picture from Helsinki, another site where we are charging, let's say there is two 300 kilowatt pantograph charging sites next to each other, so both direction on the street, but we have only single 300 kilowatt power shared by the units. So if there happens to be two buses at the same time, they can share the power to 150, and then when a single vehicle is there, then they get immediately 300 kilowatt because of the limitations of the grid. And this is actually working really well in practice. So that was for today, all from my side, to give a little bit different view from the, let's say, public transportation focus of charging.
Lovely. Thank you so much, Tommy. And thank you as well to Patrick, Stuart and Sarah for your excellent presentations today, which were all incredibly insightful and informative. Following this, we will now move on to our question and answer session. So I would like to encourage all of our speakers to turn their cameras on, and we will begin. As well as a quick reminder for our audience that you are still more than welcome to submit your questions using the panel in the menu on the right, and we will do our best to get through as many of them as possible in the next 10 minutes. So without further ado, let's take a look at the first question. So I have quite a general one that I would like to ask all four of you, and I think, Patrick, I'd like to come to you first. And I'd like to ask you all, in which area do you see the future of e-mobility? So Patrick, I don't know if you'd like to share your thoughts?
Yes, the first step will be these activities which we are already mentioned with this megawatt charging activity. This will be one point with these e-trucks, and we see this also for the buses and the trucks and the both. This is one step, certainly, yes.
Fantastic, thank you. Does anyone else have any thoughts to add to that?
I think this is what we are seeing within the industry also, that from road vehicles, this is moving also to off-highway, let's say outside of the road moving vehicles. So I think in the long run, everything that moves can be electric.
Yeah, we do agree with that one. Even the dump trucks, the bigger trucks, so that's fantastic, yeah.
Brilliant, thank you. So the next question that I have is probably best directed at Tommy, which one of our audience members has asked, what is the average time to quickly recharge an EV? And is it likely that this will increase in the future?
Quickly charge an EV is a good question, how quickly you need to charge it. Today, when we look at from the data from our cloud system, actually, in an advanced market like in Norway, the average charging time is about 10 minutes in a public charging, because people are not filling the batteries anymore to 80% or 100%. They are filling the batteries to get to the next location and probably have home charging in the other side. And when I compare the data, for example, the Finland charging, then the average time is about 20 minutes or 15 minutes. So it is basically infrastructure supports the movement, and basically many places you are not talking about the power anymore, you are not talking about the time. Again, pointing out to Norway, where the bigger question is the charging queues than the time, that you need to provide enough connections that the people can do something else when they are charging. So I think as you have more electric vehicles, you have more experience, you are not talking about so much anymore about the charging time or the power, it's the availability of charging in different places.
Absolutely, thank you. I don't know if Sarah, Sture, if you have any thoughts to add to that, or even Patrick.
Yeah, Sarah, do you have some thoughts about that? Smooth service.
Yeah, I think that's a really good point to have. When people can charge, they can also do something else, and that people are not, like you said, Toby, charging from 0 to 100 at the same time necessarily, but they're charging when just to get to the next point. I think we see that in the behavior as well.
Yeah, and we can totally agree that Tommy already mentioned the problem actually will be the availability of this loading infrastructure. If we don't have it, it doesn't matter if you have 10 minutes or 15 minutes to recharge it. But nevertheless, we are on a good way in this case, but we have to do it like Sarah and Sture already mentioned with Oslo. This until 2025 with 100%, this should be the goal.
I think it's important with goals, something to stretch after, because it forces us to do things a little bit faster. Not yet there, but I mean, if it's not 100, if it's 95, it's still much better than 50, so why not? Let's go for it, yeah.
It's also interesting to see from the data that single charging point with 300 kilowatt gets less visitors than a place which has a 6 on average 100 kilowatt charging points, because people are trusting those sites more.
Mhm.
That's what we actually think what's the future and how it should be that.
Yeah, and maybe the onboard charger and the different models explains some of it, but yeah, you're right, Tommy. People are more testing out, see what is the best way for them to do it. I think they even are looking at the price models. So yeah, maybe 50 is good enough, especially in the winter when it's cold and you don't get so much anyway. So I'm not sure, but yeah, you need both at least. Both the high performance DC chargers and the more normal. Yeah.
Depending on place, not everywhere you need a high power charger. You need something else as well. If you have a, let's say, grocery store stop, which is normally at least 20 minutes, you don't need 350 kilowatt in there. So it's something else.
Yeah, and grocery makes sense because then you normally use like 20 minutes inside the store, and that's perfect for fast charging.
And a roadside restaurant owner would like the people to stay longer than 5 minutes anyway.
I guess so.
From that
so.
perspective.
Yeah.
Fantastic, thank you. And then, so the next question I have is another one for all four of you. And I wanted to ask your thoughts on what needs must EV charging infrastructures be able to meet in order to ensure that the switch to e-mobility will be made by everyone. So Patrick, I don't know if you'd like to kick us off with your thoughts on that.
Can you repeat the question, please?
Yeah, absolutely. So it was, what needs must EV charging infrastructures be able to meet in order to ensure that the switch to e-mobility will be made by everyone?
Yeah, the first step is in the head of each of us to see that this should be the future for us. All these renewable activities have to be done, and some of this is also the government behind them. If you have a goal with the government and the government supports this is the important stuff. Right now we are discussing in Switzerland also this until 2020, 2050. We have these goals, and this will be, but we have to support them, and step by step. In the first step, we have to help the people this. We have to do the infrastructure, which Tommy already mentioned, and then I think we are on a good way, but it needs time.
Absolutely, thank you. And Tommy, any thoughts to add to that one?
I think also it was good that Sture mentioned the home charging. It's availability of home charging and overnight charging is at least the personal cars is very much in a key position that normal people can start using. Because Kempower is not in that business, but that's also my personal opinion that basically when you stop for a long time, you should be able to plug the car in, and what's a longer stop than spending the night. So it's a one key thing that this is and somehow this maybe needs some support also from the things. But I think the best example what we have is the people in Norway, that if you support let's say the car buying, the infrastructure will follow, because it's a basic need, and basically then it goes to clever solutions that are serving the public when it comes from the normal market, let's say normal market play, and then the subsidy play. As a charger manufacturer, I don't like the subsidies very much, which might be surprising, but it might lead to wrong investments. Actually, you're not making it by the, let's say, user needs. You are making it because consultant defines certain kind of equipment, and you get support for that.
Fantastic, thank you. And then Sture, Sarah, to finish us off, any thoughts to add to that as well?
Yeah, absolutely. I do agree with Tommy. It's very hard for public entities to pick technological winners, but we have a very long and good cooperation with private sector, and also using joint venture. We did that for the first time with Fortum, which is also Finnish, as you know, Tommy. Quick charging, fast charging operator. And what we did was triple the market in 1 year. according to Fortum, they wouldn't have done that so fast if we hadn't pushed it a little bit. But they used the same price structure, the same system they always do, and that helped us. Now we are more into ensuring that we have joint ventures with several companies, so you are increasing competition. And in the future, I hope that whole network of public chargers will be open for all operators, which is qualified, so they can just welcome to our shop, they can sell their services, we can do things together. But in the long run, I think safety net, you need DC charging. Home charging is number one, but you need those DC chargers. Also for the professional users, like Tommy mentioned, like the big ships, trucks, stuff like that. So we need it all. This market will boom. So, and I can say that we have a very good experience with your products, Tommy. You have a lot of, and the reason why we love those chargers are they are so slim. So the footprint, especially in the downtown areas, are much better. That's why we like slim DC chargers with satellites, which is very flexible, 50 meters away, you mentioned, important, and wireless, but we want to test out different technologies, but yeah.
Yeah, and then pointing out actually that the slow charging for heavier vehicles is actually DC charging as well, and that's, yeah. I think in a big vehicles you call 60 kilowatt is low charging, and then kind of it's a different needs with bigger batteries.
Fantastic, thank you. And I don't know, Sarah, you have anything to add to that at all?
I was just going to say that it's, I think it's really important to show the public that we are all pulling in the same direction, both public agencies and private companies, and both local and national governments, so that people really feel that this is a safe choice and this is happening, and we are going to turn transport electric, so that everyone can sort of pull in the same directions, so we actually reach our very ambitious goals together. I don't think we are able to do that if not all of us are working towards it.
Lovely, thank you. And I think that was a really good message to end on there, which was brilliant. So thank you for that. Unfortunately, that is sadly all that we have time for today. But thank you so much once again to Patrick, Stuart, Sarah and Tommy for their presentations today, as well as for answering all of our audience's questions. And on behalf of myself and all of our speakers, I would also like to thank everyone who took the time to join us today. As you leave the webinar, a very short survey will appear on your screen asking you to rate your experience today. Please do take a moment to provide your feedback, and if now is not a good time, the survey will also be sent to you shortly afterwards via email. If you could please complete it, we would greatly appreciate it. However, on behalf of Intelligent Transport and Brugg eConnect, I would like to thank you all for attending today's webinar, and we hope to see you again soon. Thank you and goodbye.
Thank you.
Thank you.
Bye-bye.
Bye-bye.